Before beginning troubleshooting, determine what is working by trying the other functions that may work in conjunction with the faulty area. By comparing what does work versus what doesn't, you will get a few steps ahead in the troubleshooting process. We recommend you always refer to the appropriate service data provided with the product while servicing. Also, refer to the consumer use, care, and installation guides for a more detailed explanation of proper operation, care, and installation. Caution: major appliances operate on high voltage levels that may cause serious injury and/or death. Disconnect power before servicing. Many appliances have sharp edges that may cause injury. Please be careful when servicing. If measurement is required with the power on, use alligator meter clips to measure hands-free. This program is an independent production and is not sanctioned by nor considered as a representation by any appliance manufacturer. The water level knob gives you the option of selecting the water level desired by simply turning the knob. This knob gives you 3 options for wash temperature: hot, warm, or cold. Rinse cycle is always cold water. The fabric softener operates by centrifugal force. After the liquid fabric softener and water is poured into the dispenser and the machine goes into the first spin cycle, the liquid is forced up the sides and out into the temporary holding slots of the dispenser. When the spin cycle stops, the liquid falls into the tub. It is recommended that the fabric softener dispenser gets cleaned occasionally. Please refer to the appropriate owner's manual for further instructions. To operate the cycle control knob, push it in and turn it clockwise to the appropriate cycle and wash time. To start the washer, simply pull out the knob. This washer will pause briefly between cycles. These pauses are a normal function of this product. You have a choice of regular or delicate drying temperatures with this product. You may select several different options, including electronic dry, which provides automatic sensing of the amount of moisture for both regular fabrics and permanent press. The time dry options include minutes, which you can select for drying time. It also includes a wrinkle release and damp dry selection. An air fluff selection is also available for tumbling with no heat. Refer to the user's guide for additional information on drying instructions. To clean the lint filter, simply pull it straight out. It is recommended that the lint filter get cleaned after each use. The transmission, brake, and radial bearing disassembly and service will not be covered in this program. Refer to the appropriate Maytag service data for additional information. Before beginning service on any product, we always recommend you refer to the service data provided by the manufacturer prior to performing any service. To remove the access panel, take out 2 screws and tilt it forward. The service information for the dryer, timers, and other controls is located behind the access panel. To remove the control panel, first remove all knobs. The washer timer knob can be removed by pulling out the insert, then prying off the holding clip. You may now remove the knob, dial, and spring. To remove the dryer timer knob, pry off the insert and unscrewing the nut, then pull off the dial and knob. Remove the temperature and load size knobs by pulling them off. To gain access to the controls, remove the mounting screw, then pull the fascia to the right and lift it off. Remove the washer timer by taking out 2 screws securing the timer and 1 screw securing the wire harness. Push the timer towards the back of the machine and drop it out through the access panel. Control switches may be serviced by removing 2 screws holding the mounting plate and pulling the panel forward as shown here. When reinstalling the panel, make sure you do not put the wrong screw in. As you can see here, there is not much room between the panel and a voltage source. To service the dryer timer, remove the 2 screws holding it. The service information for the washer is located inside the washer behind the front panel. To remove the front panel, take out 2 Phillips head screws located near the bottom. Swing the panel out from the bottom and lift it out. The water level control can be replaced by squeezing the plastic tabs with pliers and pulling the assembly off. To remove the top cover, take out the 2 3/8-inch screws under the front cover. Disconnect the bleach hose, then carefully lift the lid and cover. Remove the water injector housing by taking the screw out and sliding it out. Then disconnect the lid switch. To service the lid switch, remove the 2 screws holding the switch assembly in place and lift it off. To replace the capacitor, you will need to remove the rivets indicated here. The replacement capacitor will come with new rivets, moisture seal, wire, and clip. For ease of demonstration, during this segment, we have removed the washer from the dryer assembly. The agitator can be removed by loosening the screw on the side of the agitator enough to lift and pull the agitator off of the shaft. To remove the tub cover, unclip the tabs and lift it out. The balance ring is attached with 3 tabs. To remove the balance ring, place the point of a small screwdriver or pencil into each of the 3 small holes, releasing the tabs to remove the balance ring. Take care in removing the balance ring. It is heavy and fragile. Remove the clamping nut by using the special Maytag spanner wrench. The clamping nut uses left-hand threads, so make sure you loosen it in the clockwise direction. Pull off the clamping nut washer and lift out the inner tub. The mounting stem is held in by a set screw that will need to be removed. Using the Maytag spanner wrench again, remove the mounting stem. It is also left-hand threaded. You now have access to the O-ring and boot seal. The boot seal can be removed by twisting it clockwise. Loosen clamps and remove the drain hose and air dome from the outer tub. Remove 3 bolts with nuts and washers holding the outer tub to the tub braces. Lift out the outer tub. To replace the pump, first disconnect hoses, then tilt the washer back and remove the belt. Mark the front of the pump with a marker to remember its position. Remove the 3 screws from the bottom base holding the pump. Tilt the pump and lift the pulley through the base. When replacing the belt or pump, it is important to adjust the placement of the pump so that there is a 1/4 inch space between the 2 sides of the belt as shown here. We will not cover service to or disassembly of the door, door seal, door handle, hinges, tumbler bearings, tumbler seals, pads, blower, or related components. Refer to the appropriate service data for additional information. After removing the control panel cover and gaining access to the electrical controls as described earlier, you can remove the front panel by taking out 2 Phillips screws located on the top corners of the dryer. Lean the front panel forward and disconnect the door switch wires. Now lift the panel out. To remove the outer half of the air duct, take out the screws along the edge, then lift it out. This will give you access to the filter screen holding assembly. To remove the filter assembly, take out the 4 screws from inside the tumbler and lift it out. To gain access to the drive belt, you will have to remove the tumbler front. Unclip the idler tension spring. Then reach underneath to remove the drive belt from the motor and pulleys. You may now lift out the tumbler. To replace the belt, simply route the belt around the drive motor pulley and the idler pulley. Then hang the belt over the top edge of the rear wall and install the tumbler. Place the belt over the tumbler while making sure the flat side of the belt is toward the tumbler. Rehook the idler spring, then rotate the tumbler in the clockwise position several revolutions so that the belt can seat itself into the proper position. Reinstall the tumbler front and panel. To service the drive motor, you will need to first remove the tumbler and belt as indicated earlier. Take out 2 screws holding the motor to the frame. Take the screw holding the cone to the base and also the screw in back of the cone holding the cone tab to the inlet air duct. When you find a problem with either slow or no fill, the obvious place to check is the supply itself. Make sure you have sufficient water pressure to the fill hose. Also, you will want to remove the water filter screen inside the water valve and examine it for debris or sediment. If you encounter a problem where the washer will not fill, check the water valve with your ohm meter. Each solenoid should measure out to approximately 870 ohms. An easy way to troubleshoot is to first remove power. Then unplug the wiring harness between the washer and dryer frame assembly. If you look closely at the plug connected to the washer, you will find a pin labeled 1 on the upper right-hand corner, and also a pin labeled 15 on the lower left-hand corner. To find the pin number you want, simply count over to the one you need to check. For example, let's say we want to measure across both water valves in series. As shown here, the circuit would be from pin 5 through the solenoid for hot water, through the white connection wire, into the cold solenoid and out pin 11 of the harness connector. So let's measure across pins 5 and 11. Here is pin 5. That's one connection. And now pin 11. It should read approximately 1740 ohms. As we mentioned earlier, each valve should measure approximately 870 ohms. If you add them together, it's 1740 ohms. That's what we have, so the water valve solenoids are good. You may also want to check continuity from the harness connector to where the water level switch hooks up through the water valve itself. To do this, connect one meter lead to pin 9 and the other to pin 11. If you look at the circuit, what you are really measuring is from this point, which is pin 9, through the normally closed contacts in the pressure switch, indicating there is no water in the tub through the various wires, the fuse, and on through the circuit we covered earlier. If you encounter a problem where the water selection is not correct or it will not fill to the level selected, check the water level selector by measuring across the switch connections. You should have continuity between the gray wire and the various points on the switch that correspond to the selections made. For example, if you select the small load, you will have a connection between connector 7 and 1C as shown here. When selecting a large load, you will have a connection to connector 3C from 7. If you encounter a problem where the washer will not stop filling even with the washer off, this indicates a stuck water valve solenoid. Replace the bad water valve. For problems associated with the motor not running, the first logical place to check is across the load itself. To do this, measure across the motor windings with the power on. If you read approximately 120 volts, you will need to perform a motor test by using a motor test cord. Refer to the appropriate Maytag service data on this procedure. A faulty lid switch could also cause a no-spin or agitate condition. To check the lid switch, remove power and check across pin 8 and pin 12 of the harness plug. You should read 0 ohms with the lid down and an open circuit with the lid up. Also check across pins 1 and 12. You should read 0 ohms with the lid down and an open circuit with the lid up. If you have checked the lid switches and do not read 120 volts at the motor, you may have a problem with the timer or its connections. Refer to the service data for the proper timing sequence and connections for the various functions of the timer and its contacts. If all electrical indications seem fine, you may need to examine the clutch or possibly the transmission for mechanical failure. To check the timer motor, simply place your meter leads across the motor connection itself, and with the timer in the run position, you should read 120 volts. If not, check from neutral to one of the timer motor connections. If you read line voltage, this indicates an open at this point on the circuit, indicating a faulty timer. Also, remove power and check across pins 8 and 1 of the harness connector. You should read 0 ohms with the lid down. If not, this indicates a fault in the lid switch assembly or its connections. Since the pump is basically a mechanical device and only operates during spin, most causes for failure will be due to mechanical problems or something clogged in the pump. Before starting to disassemble anything, always check to make sure you have the correct voltage to the product. Check across the outlet terminals to make sure you have AC voltage. Once you have verified that you have power, check any possible mechanical failures. Look for a broken or loose belt, broken idler tension spring, or other idler pulley problems. The drive motor begins operating when the push-to-start switch is depressed, completing the circuit from neutral through the door switch, the centrifugal switch, both the start and run windings, at least momentarily, then into the overload protector. The circuit continues through the thermal fuse, timer connections, then on to L1, completing the circuit. Once the motor begins turning, the centrifugal switch changes states, taking the start winding out of the circuit, and also bypassing the push-to-start switch. To check the drive motor, measure across the red and gray wires connected to the motor. You should read 120 volts. If you do and the motor does not run, this indicates a failure in the motor windings, centrifugal switch, or overload protector. If the unit runs for a short while, then shuts down, look for a blocked impeller on the motor or lint buildup around the drive motor. These problems will cause the thermal overload to open. If you find the dryer tripping the circuit breaker, you may have a bad motor, shorted heating element, or incorrect house wiring connection to the product. The heating element operates when the motor begins turning. This closes the centrifugal switch connections, bringing current to the heaters, the high limit switch, and the cycling thermostat. It connects through the timer connections, provided that the timer knob is in either the regular fabric, permanent press, or time dry positions. If the temperature switch is put into the delicate position, this allows current to bypass the heater whenever a designated temperature is reached. To check the element, remove power and measure directly across it. You should read approximately 12 ohms. To check the high limit device, measure across it. You should read less than 1 ohm. The cycling thermostat will read approximately 12 ohms, and the limit switch on the cycling thermostat, that is the blue and purple connections, will read less than 1 ohm. The dryness sensor and associated circuitry electrically determines the moisture level of clothes. It does this by using 2 stainless steel sensors mounted on the holder. They are mounted close together and are connected to the circuit board located in the back of the dryer. As the wet clothes tumble, they will occasionally drop across the 2 sensors and complete the circuit from ground back to the circuit board. This occasional connection to ground will cause the silicone-controlled rectifier to conduct, which keeps the voltage drop across the timer motor very low, essentially keeping it from advancing. As the clothes dry, the charge on the capacitor builds up, causing the SCR to shut down and not pass current. This allows 120 volts to appear across the timer motor, allowing it to advance. To check if the sensor is working, take a wet cloth or paper towel and place it inside the tumbler on top of the sensors, in a way so that it does not tumble. Place your meter leads across the timer motor connections and turn on the dryer timer to the permanent press selection. While monitoring voltage, press the Start button. Notice that the voltage is very low. Now remove the wet towel and start the dryer again. Check the meter. You should see the meter rapidly increase to 120 volts. Caution: when you have completed service on any appliance, make sure you have reconnected all grounding devices to the original position. As we said in the beginning of this program, when troubleshooting, it is best to first try all other functions that may work in conjunction with the faulty condition. By comparing what does work to what could cause the existing faulty condition, you will be able to isolate the problem and save a few steps in the troubleshooting process.